acid-base titrations. This is the first video of this series. We are going to learn this lesson very slowly, step by step, through problems. Now let's go to problems. First one, 32 milliliter offers 0.75 m solution of sulfuric acid is required to neutralize 46.1 milliliter of sodium hydroxide solution. Find the molarity of the sodium hydroxide solution. This is the chemical equation. H2SO plus, H2SO4 plus, NaOH, we get Na2SO4 plus H2O. This chemical equation is not balanced. First of all, we have to balance this chemical equation. Let's balance it. Then on the left hand side, H2SO4 plus 2NaOH. On the right hand side, Na2SO4 plus 2H2O. Now you can see the ratio. To react with 1 mole of sulfuric acid, 2 moles of sodium hydroxide are required. Ratio 1 to 2. To react with 1 mole of sulfuric acid, 2 moles of sodium hydroxide are required. Third 2 milliliter of 0.75 m solution of sulfuric acid. M means molarity. That means in 1000 milliliter or 1 liter of this sulfuric acid solution, there are 0.75 moles of sulfuric acid. Molarity. For this reaction, we use 32 milliliters. We know volume 32 milliliters. We know molarity of the sulfuric acid solution. Now we can find in 32 milliliters of the sulfuric acid solution how many moles of H2SO4 are there. Let's find it. We know the molarity and volume of the sulfuric acid solution. Therefore, we can find the number of moles in 32 milliliter of sulfuric acid. In 1000 milliliter of H2SO4 solution, there are 0.75 moles of H2SO4. Now we have to find in 32 milliliter of sulfuric acid solution how many moles of H2SO4 are there. In 1000 milliliters, there are 0.75 moles of H2SO4. Now we want to find in 32 milliliter of H2SO4 solution how many moles of H2SO4 are there. We can find it in this way: 0.75 moles of H2SO4 divided by 1000 milliliter of H2SO4 multiplied by 32 milliliter of H2SO4. 0.75 mole H2SO4 divided by 1000 milliliter H2SO4 multiplied by 32 milliliter H2SO4. We should cancel out units. Milliliter H2SO4, milliliter H2SO4, then we get 0.024 moles of H2SO4. In 32 milliliter of this sulfuric acid solution, there are 0.024 moles of H2SO4. To find the number of moles, we can use formula of molarity M equals N divided by V. If we want, we can use this formula, but we did not use this formula now. Ratio to react with 1 mole of H2SO4, 2 moles of NaOH are required. I have written this ratio again here. To react with 1 mole of H2SO4, 2 moles of NaOH are required. To react with 1 mole of H2SO4, 2 moles of NaOH are required. Now we have 0.024 moles of H2SO4. Now we need to find, to react with 0.024 moles of H2SO4, how many moles of NaOH are required? We can find it in this way. 2 mole NaOH divided by 1 mole H2SO4 multiplied by 0.024 moles H2SO4. 2 mole NaOH divided by 1 mole H2SO4 multiplied by 0.024 moles H2SO4. We should cancel out units. Mole H2SO4, mole H2SO4, then we get 0.048 moles of NaOH. To react with 0.024 moles of H2SO4, 0.048 moles of NaOH are required. Now we have found number of moles of NaOH. We know the volume of NaOH solution 46.1 milliliter. We have found number of moles in this 46.1 milliliter of NaOH solution. We have found number of moles of 46.1 milliliter of NaOH. According to our problem, 32 milliliter of a 0.75 m solution of H2SO4 acid is required to neutralize 46.1 milliliter of a NaOH solution. That means 46.1 milliliter of NaOH contain 0.048 moles of NaOH. Now we can find the molarity, moles per liter, or moles per 1000 milliliter. In 46.1 milliliter of NaOH contain 0.048 moles of NaOH in 46.1 milliliter. But when we find the molarity, we have to find how many moles of NaOH are there in 1000 milliliters. We can find it in this way: 0.048 mole NaOH divided by 46.1 milliliter NaOH multiplied by 1000 milliliter NaOH. 0.048 mole NaOH divided by 46.1 milliliter NaOH multiplied by 1000 milliliter NaOH. We should cancel out units. Milliliter NaOH Then we get our answer 1.041 molarity. Molarity of that NaO solution is 1.041. We have been asked to find the molarity of the NaO solution. Now we have found it. 1.041 molarity. That means 1 liter of NaO solution contains 1.041 moles of NaOH. If we want, we can use the formula of molarity to find the molarity. It's not difficult. In our earlier videos, we use this method. M equals N divided by V. This is the formula of molarity. N, number of moles of solute, V, volume of solution in liters. We have found number of moles 0.048. Volume we have been given 46.1 milliliters. But when we use this formula of molarity, we have to convert it to liters. 46.1 divided by 1000, then we get 0.0461 liters. Let's substitute these values to formula. 0.048 mole divided by 0.0461 liters. Then we get molarity 1.041. 3 decimal places are enough. I use my calculator. The answer 1.041 molarity. If you can understand this video, please subscribe our channel. If you can't understand this video, please watch this video again and again. Then you will be able to understand. Thank you very much for watching. God bless you.